Hello everyone, welcome back to this video series on clinical SAS SDTM programming. In this video, we will see an example of procedures dataset in which the procedures or the information is collected related to the transfusion and the date of transfusion, type of transfusion and the volume of transfusion and the reason for which a transfusion had to be administered is being collected. So here is some general description about the procedures dataset. So in clinical trials, subject would be given the investigational drug or a matching control, and we call these as study treatments. And the relevant information for these study medications is captured as part of EC or EX domains. Any other medications taken prior or concurrent with the study or during the follow-up phase of study are reported in CM domain. So like the concomitant medications, patient may undergo some procedures which may have some diagnostic, preventive, therapeutic or palliative effects. So some example procedures could be the patients may be undergoing CT scan of the whole body or specific biopsy is performed for any specific sample specimen, and then procedure like wisdom teeth extraction or some eye examination or performance of an endoscopy or radiotherapy or performing echocardiogram to test the cardiovascular health. So these are some of the procedures that could be needed uh, while the patient is on study or which could be prior or during the follow-up phase. So SDTM standard has a domain named procedures to capture the occurrence of these procedures. So if it is investigational drug related information, then we capture it in EC or EX. Any other medications, so we capture it in CM domain. So if it is a procedure, if an intervention that is a procedure, so we capture it in the dataset called procedures, which is abbreviated as PR. Any results coming out of these procedures should be captured in their own individual findings or findings about domains. So what does this mean? Say for example, if echocardiogram is performed, so I think we already have it here. So we'll see example, the occurrence of echocardiogram procedure is captured in PR domain and the resulting findings like left ventricular ejection fraction and right ventricular ejection fraction are to be reported in CV domain. So which means the date when the echocardiogram is performed or whether it is performed or not, that would be captured in PR domain. But the resulting findings from echocardiogram. So when you perform the echocardiogram, you get some results out of it. Those results have to be reported in the specific domain. So here in this example for echocardiogram, the results are to be stored in CV domain. So important thing to note. So only the procedure performed the details will be in PR domain, and the relevant findings will be in the associated findings domain or findings about domains. So what type of information is typically collected or presented for procedures domain? The name of the procedures. So is the procedure pre-specified? Say for example, in some of the studies, it could be expected that a CT scan has to be performed. So if it is pre-specified in the protocol, we specify whether it is the CT scan had to be collected in pre-specified manner. So if pre-specified, we collect whether it is performed or not. If it is not performed, why? The reason that procedure is not performed will be captured in PR domain. And if it is done, so we will capture the date or start date of the procedure. So some of the procedures could occur on a particular single time point, or some procedure may need some duration. So in that case, we will have the start date and end date. So if it is echocardiogram thing, so we may just capture the date of occurrence. So say for example, if it is a transfusion, we may have started the transfusion at one particular time point, and the transfusion may go on for few minutes to few hours. So we'll need end date as well in that case. So if we need start and end dates, we'll use start and end dates. If it is a single point in collection, we'll use PRDTC or the date of procedure. And then we will collect the information related to the status of procedure, whether it is ongoing or ended. If it ended, so as discussed, we would collect the end date time of procedure. So this is not medication, so this should have been procedure. And then dose or dosing unit of the procedures wherever it is applicable. Say for example, we if it is radiotherapy, we collect the intensity of the radiation therapy that is administered in the dose and dosing unit variables. And then the frequency of administration. So whether the procedure has or whether the radiotherapy has occurred once daily or twice daily or once in a month kind of thing will be reported in frequency of administration variable. And then we may also need to collect the route of administration if it is of relevance. And then location or laterality of the procedure. Say for example, the subject may undergo X-ray or CT scan of specific hand or leg. Then we will be capturing that location of the procedure, and the laterality would take the values of right or left depending on where if the laterality is applicable or not. And then indication for which the procedure is performed. So this is some information that would be collected typically for procedures, so as needed. So we will now move on to the example CRF that we would be seeing. So here we have our CRF, which is used to collect the information for transfusions. So here we are capturing the start date of transfusion and then end date of transfusion and the transfusion type, whether it is whole blood that is being transfused to the patients or only platelets or packed red blood cells. So, and then we have the total volume transfused is being collected and the total volume unit and the reason for transfusion. So here if we see, the variable named PRSTDAT would be present in the raw dataset named transfusion to collect the start date of transfusion information. Similarly, PRENDAT would be used to store the end date of transfusion, and PRTRT would be used to store the one of the possible transfusion types of whole blood, platelets, or packed red blood cells. And then we have the volume administered is stored in a variable in PRVOL in the raw data, and then PRVOLU for total volume unit, and the reason for transfusion is present in a variable named PRREAS. So let us see now the annotations, SDTM annotations for these individual questions. So start date of transfusion. So let's see where this has to be mapped to. So this information from this variable PRSTDAT in the raw data has to be mapped to the variable PRSTDTC. And then PRENDAT would be mapped to PRENDTC. And then the transfusion type, which is coming in a variable named PRTRT, has to be mapped to a same named variable in SDTM. So here the raw variable name is same as the SDTM variable name that we have to map it to. And then we have total volume transfused. Let's see to which variable this needs to be mapped to. So we need to map the information coming from PRVOL variable to PRDOSC, PR dose variable. And then total volume unit. So it has to be mapped to dosing unit variable, which is PR dose U. And then we have the reason for transfusion, which is coming in a variable named PRREAS. So here we are being asked to map it to the variable PRINDC, so which is indication for which the transfusion has occurred. We have seen the questions that are being asked for related to transfusion, and we have seen the names of the raw variables that are being that will have the data collected for, and then we have seen the SDTM variable names to which particular information has to be mapped to. Now let us move to the specification. So here we have the variable name, label, type of the variable that has to be used, and the general comment, and then the derivation logic that has to be used for the variables which are directly coming from transfusion. So for study ID, we are being asked to use the value of myCSG. And then for domain, so as this is related to procedure, which is abbreviated as PR, we are being asked to use the value PR in domain variable. And then for USUBJD, we are being asked to concatenate the value present in project and subject from transfusion dataset with a hyphen in between. And for PRSeq, we are being asked to sort the records based on USUBJD, PRCat, PRTRT, start date of the procedure, end date of the procedure, and assign as 1 on the first record of each subject and increment by 1 for each subsequent record for that subject. And then we have PRSPID. It says populate using transfusion record position variable. So in 3-digit format, padding with leading zeros where applicable. And then we have PRTRT. So we have seen in the CRF annotation that we had a same named variable named PRTRT that has to be used to create PRTRT. So specification is mentioning that. So populate using transfusion.prtrt. And then PRCat. So we are being asked to populate it as transfusions explicitly. So this information is not coming from anywhere in the CRF, but as this data is related to transfusion, we are populating it as transfusions in PRCat variable. And then for PRINDC, so we were asked to use the value present in PRREAS from transfusion dataset. So we are given that specification here. And then for PRDOS, so we are being asked to populate the value from PRVOL variable of transfusion dataset. And for PRDOSU, we are being asked to use the value from PRVOLU to populate DOSU. And then we have epoch variable. It says populate using SDTM SC epoch by comparing PRSTDTC with SCSTDTC and SCENDTC of each element of the subject, and populate as treatment when the record falls on the boundary of screening and treatment elements, and populate as treatment when the record falls on the boundary of treatment and follow-up. We know that in SC dataset the record structure is one record per element and there would be no gaps between two elements, which means the end date of one element will be the start date of next element. So the boundary for treatment could be present between screening and treatment and follow-up. So when the record is falling on the boundary of screening and treatment, we are being asked to populate as treatment. Again, there could be a case wherein the record could be falling on the end date of treatment, which could be our start date of our follow-up. So if that is the case, again we are being asked to give preference to treatment epoch. So we will be seeing the derivation for it in the programming on how this can be handled. And then we have PRSTDTC. So we are being asked to populate using transfusion PRSTDAT and transfusion PRSTTIM. I'm not sure if time was collected in the CRF, but again, so we'll be using PRSTDAT to report our. So let's take a quick look at our input data. So and see if we had time collected. So we do not have time. We have time collected. So we'll be using this information to populate. Though in CRF, I think I have missed adding that time component. But so both date and date time component for start would be used to populate PRSTDTC. So let me come back to the specification. So we would be using the information from PRSTDAT and PRSTTIM to populate our PRSTDTC variable, and similarly we would be using PRENDAT and PRENTime to populate PRENDTC variable. And then we have study day variables for start date of the procedure and end day, PRENDY for end date of the procedure. So we are being asked to check PRSTDTC whether it is on or after reference start date. So if it is the case, so we are being asked to add +1 to the difference between PR start date and reference start date. Otherwise, we just need to populate our PRSTDY with the difference between PRSTDTC and RFSTDTC. Same goes with our PRENDY, but we will be using PRENDTC. So I would just like to add one clarification. So this is example CRF that I have created to show you how the annotations work. So this is not exactly the form that is used to create our input data set. So that's why I do not have time components for start and end dates of transfusion presented here. But I'll try to add this post making this video if possible. So now let us move on to the programming. So here on the left hand side of my screen, I have my SAS program, and on the right hand side, I have my input dataset and output dataset. That would be an intermediate dataset that will be generated out of the codes, and then the final dataset that is created. So let us take a quick look at our transfusion dataset. We have one record here for subject 1001, and here if we see, we have the start date collected, start time collected, and then end date time, and the type of transfusion coming in PRTRT, and then the volume administered, volume in units, and the reason why the transfusion had to be made. And let us come back to the DM dataset. Here we have data for 3 subjects, out of which only one of the subject needed one transfusion. And then we have start date and end date of each of the elements or epochs for all of the subjects present in DEMOC dataset. So we will use these 3 datasets, DM, SE, and our transfusion dataset to create our RP dataset. So we'll now come back to the programming. So we are using our transfusion dataset as input and creating a dataset called PR01. So here we are assigning the text of my CSG to the study ID variable and the uh, abbreviation PR for domain variable. And then we are creating useObj by concatenating the value present in study ID and subject with a hyphen in between. So we are achieving that using catex function. And then we are creating our PR SPID variable. So by converting the value present in PR record position to 3-character wide string with by padding leading zeros where applicable. So Z3 format actually adds your leading zeros when the total number of characters present in your input variable is less than 3. So if you have a value of 1, so when you apply Z3 format to that, it would be converted to 001. If you have a value of 11, so it would convert it as 011. If you have a value of 123, so it would just give you the value of 123 because we already had 3 characters in the input variable. So if the total number of characters in the input variable is less than 3, so it would add those many number of leading zeros based on number of characters present in your input value. So we are creating PRSPID by using put function on record position variable with Z3 format. And as per the specification, we were asked to use the value of transfusions in PRCAT. So we are assigning that here. So here we are converting the PRSTDAT to ISO 8601 notation using input function first on PRSTDT by converting it into numeric format and then further converting it back into character notation using YYMMDD 10 dot. And then to that ISO 8601 notation date value. So if time is not null, so we are concatenating time value to the ISO 8601 date value with a T in between. So we'll see when we take a look at PR01 and how these values are coming like. And then we are applying similar processing on PRENDTC. To create PRENDTC, we are first converting the character value present in PRENDT DAT to numeric value and then further converting it into ISO 8601 notation using YYMMDD 10 dot format. And then if time is present, so we are concatenating the time value in PREN time to the ISO notation value of date which is already present in PRENDTC with a T in between. And then for PRTRT, it was a copy variable from PRTRT. So I am assigning the value from PRTRT to again to PRTRT. And then for PR dose, so we were asked to convert the value present in PR volume to PR volume to PR dose. So PR volume is present as a character variable. So I am converting that to numeric format using input function and best.in format. And then for PR dose U, we were asked to populate with the value coming from PR VOLU, which is nothing but the unit of volume. So, and then for PR INDC, we were asked to use the value from PR REAS. So we are assigning that to PR INDC variable. Now let us take a look at PR01 variable and see how our derived variables are looking like. So we have created study ID, domain, PRSPID. So here if we see the record position had a value of 0. So but we were asked to convert it into 3-character wide string by concatenating leading zeros if the total number of characters is less than 3. So 0 is becoming 000. And for PRCAT we just simply assign the value of transfusion, so it is coming here. And then we have PR dose which is coming as 100, which is populated from PR VOL, and PR dose U is coming from PR VOLU. And for PRINDC, this is coming from the PRREAS variable, so we have it. So let us take a quick look at our date variables as well. So here we have PRSTDAT as 28 Jan 2010 and the start time is 10:30. So let us see the ISO 8601 notation of it. So here if you see 2010 01 28 and we have both date and time, so they have to be separated with a T in between. So we have T in between and 10:58 is 10:30 is being collected is concatenated. So 28 Jan 2010 and time is 10:30 for PRSTDTC. And then let us examine the value in PRE and DTC. So it ended on the same day but at 10:58 a.m. in the morning. So we should have 2010-01-28 with a T in between and then 10:58. So let's see if that is the case. 2010-01-28 with T in between and 10:58. So we have combined the information from these two variables and created our PRE and DTC. So now let us move to the next part of the program. So which is creation of our study day variable. So here we are fetching our RFST into our PR domain by merging PR01 to demographics dataset at subject ID level. And then we know that dates in ISO 8601 notation are in character format, but in order to calculate study day variables, so we need to have those converted into numeric format. So we are converting RFSTDTC to numeric format using input function and YYMMDD10.in format, and we are employing the same logic to create numeric versions for PRSTDTC and PRENDTC as well in these lines of code. And then we are calculating or deriving our study day. Using this logic, we are deriving our study day when both RFSTDT and PRSTDT has a not missing value, and we are creating our PRSTDY as difference between PRSTDT and RFSTDT, and then adding 1 if PRSTDT is greater than or is equal to RFSTDT. So this expression would result to a value of 1 if this is true, otherwise it would result to 0. And similarly, we are creating our PRE and DY variable. And then next comes our epoch variable. So here I am using SE02. Let's take a quick look at our PR02 dataset and see how our PRSTDY and PRENDY are appearing. So both of them were falling on the same day, so we should have PRSTDY and PRENDY the same. So we have that populated correctly. So let us now see the derivation of epoch variable. So here I am creating it using SE dataset and creating a dataset called SE02. In this I am creating a new variable called short, and I'm just creating an abbreviated version of the epoch value. So if epoch is screening, I'm using an abbreviation of SCR. If it is treatment, I'm using an abbreviation of TRT, and if it is follow-up, I'm using an abbreviation of follow-up. So what I'm trying to do here is to get the start dates of each element in onto a single record for each subject. So we have seen that in SE we'll have one record per each element. When there exists only one element within each epoch, so we'll have one record per each epoch. So here that is the case. So we are trying to get the SE/ST/DTC of each of these three epochs onto a single record. So we are transposing SE/ST/DTC, and we are indicating that the newly created variables should have the names coming from this short variable SCR, TRT, and FU. At the same time, we are indicating that the variables have to be prefixed with the value of start underscore. So when these data is transposed, we would get the variables like start underscore SCR, start underscore TRT, start underscore FU. So let us see our epoch start data set here. So here if you see, we have one record per subject with the start date of each of the epochs available as columns here. So start of screening, start of treatment, and start of follow-up. So here if you see, the first subject had all three epochs, so we have all three dates possible populated. And for the second subject, we didn't have the record corresponding to follow-up, so we have that value blank. And for the third subject, we only had a record for screening element, so we have the other two variables coming as null. And then similarly, how we have processed here for start of each of the epochs. So we are doing the processing for end of each epoch. So we are naming the uh, end dates with the prefix of end underscore. So if we take a look at epoch and end dataset, so here we have the end date of screening, end date of treatment, and end date of follow-up available per each subject or as one record per subject. Now what we'll try to do in the next step is to bring the start and end dates of each of the elements of a subject into a single dataset. So we can achieve that by merging the start dates and end dates into a single dataset at subject level. So, and we are creating this new dataset named as epoch dates. So if we see here, we have one record per subject with the start date and end date of each of the epochs present as a variable. Now we will be able to compare our RPDTC, PRSTDTC and see where exactly it is falling. So which means where the PRSTDTC is falling in, whether it is falling in between start of screening and end of screening, or start and end of treatment, or start and end of follow-up, and then populate epoch accordingly. So we will do that here in the next step. So we are now bringing the epoch start and end dates which are present in epoch dates into our PR03 dataset. So PR03 is created by sorting PR02 at subject level. So PR04 will have now each of these start and end dates of all the epochs present in alongside our PRSTDTC. So we have PRSTDTC present here. Where is it? So we have PRSTDTC available, and then we also have the start and end dates of each of the epochs available here, so that we can compare our PRSTDTC with these element start and end dates and assign epoch accordingly. So we will do that here in the next step. So here I am creating a variable called YMD by extracting the date component from PRSTDTC. So if, and then I'll check where exactly it is falling, whether it is falling in between the start and end date of screening, or start and end date of treatment, or start and end date of follow-up, and assign the epoch accordingly. So here I'm checking if my procedure start date is in between start of screening and before end of screening. If that is the case, or if the subject did not take treatment, so I'm checking if the procedure is in between start and end of screening, and I think this should have been less than or is equal to. So I'll try to correct this post making this video. So if the subject did not take treatment, so any record or procedure collected on the end date of screening has to be reported as screening. So we are assigning that here. And then otherwise we are checking if our procedure start date is falling in between treatment start date and end date of treatment. So in that case, so we are assigning the value of treatment to the epoch variable. Otherwise we are checking if our procedure start date is falling in between, uh, if it is less than follow-up start date. If follow-up start date is less than procedure date, less than end of follow-up, then we are assigning the value of follow-up to this. So we know that the end of treatment is equal to the start of follow-up. So we were asked to, when the record falls on the boundary of end of treatment and end of start of follow-up, so we were supposed to give preference for treatment. So we are doing that here, and that's why we are using start of follow-up less than procedure date less than or is equal to end of follow-up, and then we are assigning epoch as follow-up in those cases. And then finally we are creating our seek variable. So PR05, we are sorting it based on the value specified in specification for PRC creation, new subject ID, PRCAT, PRTRT, start date and end date. And then on the first record of each subject, we are assigning the value of 1 to the PRSeek variable. On the subsequent records, we are incrementing it by 1. And finally, I am creating a dataset named PR by keeping only the required variables, and also logically ordering them by specifying the same list of variables here on the retain statement and keeping only those variables. So let us take a quick look at our final dataset that is created. So here we have our procedure dataset which is in final SDTM structure. So we have study ID, domain, USubject ID, sequence variable, PRSP ID, treatment, category, indication, dose, dosing unit, epoch variable, PRSTDTC, PRENDTC, PRSTDY, and PRENDY. So this is how you can create your procedures dataset in SDTM. Thank you for watching and keep learning.